Okay, so we all know AI is pretty good at spotting things in pictures, right? A cat, a car, maybe even a tumor. But can it do what a real expert doctor does? Can it look at a complex 3D scan, zero in on the exact problem area, and then, walk you through its thinking, step by step, just like a human expert would? That leap from just seeing something to actually understanding it, that's one of the biggest hurdles in medical AI today. So let's break down how researchers are starting to clear it.
Here's how we're going to tackle this. First, we'll dig into AI's big 3D blind spot. Then, we'll look at the incredible training manual that's been created to teach it how to see. We'll see how this actually builds an AI that can reason, we'll check its report card to see how it did, and finally, we'll explore what this all means for the future of medicine.
All right, Section 1, AI's 3D blind spot. Let's get right to the core of the problem. Modern AI models, for all their power, often just fall flat when it comes to the deep, nuanced thinking that doctors do every single day, especially when they're looking at these complicated 3D scans.
And really, it all boils down to this one big question. It's not about whether an AI can find something on an MRI. It's about whether it can see that image with the same structured, analytical eye as a radiologist who's been doing this for 20 years. And as you're about to see, there's a pretty big gap there right now.
So think about how a human expert does it. They follow this really logical region-first workflow. First, they localize. They find the exact spot they need to focus on. Then, they assess that little area for any problems. And finally, they characterize what they're seeing to build a diagnosis. It's this beautiful step-by-step process, and it's exactly what AI has had so much trouble doing in 3D. And that creates what researchers call the reasoning gap. An AI might spit out an answer, right? Like grade 2 cartilage damage, but it can't tell you how it got there. It can't show its work. And for a doctor to ever truly trust an AI, it has to be able to explain its thinking, just like a human colleague would. Otherwise, it's just a mysterious black box, and nobody wants that in a hospital.
So how in the world do we fix this? Well, here's the interesting part. The problem isn't that the AI models aren't smart enough. It's more like they've been trying to go to medical school without the right textbook. They're missing the proper training manual for 3D medical reasoning.
And this chart, wow, it just lays it all out perfectly. Look at the existing datasets used to train AI. They were all missing something crucial. Some had the 3D data but no explanation of the reasoning. Others had the reasoning but only for flat 2D images. None of them had all three key ingredients: the 3D data, the precise location, what's called grounding, and that all-important step-by-step reasoning. None of them, until 3DReasonKnee came along.
And this brings us right to the breakthrough, a brand new data set called 3DReasonKnee. You can think of this as the ultimate textbook, just meticulously crafted to teach an AI how to think, see, and reason just like an expert orthopedic surgeon who's looking at a knee MRI. And we're not talking about a thin little pamphlet here. This thing is massive. It has almost 500,000, that's 494,000, high-quality learning examples. Each one of these examples is what the researchers call a quintuple, basically a complete lesson made up of 5 key pieces of information. Let's break down what's inside.
Okay, so every single lesson starts with the raw material, a complete, super high-resolution 3D knee scan taken from a massive, long-term study sponsored by the National Institutes of Health. So top-quality stuff.
Next up, the AI gets a specific task. It's not just told to look at the knee. It's asked a direct clinical question, like, assess the cartilage right here at the medial femur. It's like a professor quizzing a med student, forcing it to focus its analysis.
Then, and this is so critical, it's shown exactly where to look. A 3D bounding box highlights the precise region in the scan. It's like a mentor pointing over the AI's shoulder and saying, look right here. This is that grounding we were talking about.
Now for the secret sauce, the reasoning. The AI is literally given a clinician's chain of thought, all written out, explaining the why behind their diagnosis. This makes the entire thought process totally transparent. It's like getting to read the expert's notes. And finally, the AI gets the answer key, a structured diagnosis, complete with a final severity grade that follows established clinical standards like MOACs. So at the end of the lesson, it gets a clear, clinically relevant answer, the whole shebang. And get this wasn't just some automated computer process. This data set is the product of over 450 hours of painstaking, meticulous work by real board-certified radiologists and orthopedic surgeons.
They manually annotated these scans and wrote out their own thought processes to create this incredible AI tutor.
Okay, so we've got the revolutionary new textbook. The billion-dollar question is, did the student actually learn anything? It's time to look at the AI's report card and see what happened when they put this new training to the test.
So here's the before picture. Researchers took some of the best AI models out there and tested them zero shot, which basically means they threw them in the deep end with no specific training from this new dataset. And the results? Yeah, not great. The best model barely scraped by with 48% accuracy. It just shows how incredibly hard this task really is.
And this quote from the research paper, it just hits the nail on the head. It tells us exactly why they failed. The biggest problem was grounding. The model simply couldn't figure out where to look. When the researchers basically gave them a hint by pointing out the right spot, their performance shot up. That proves that finding the right location was a massive blind spot.
But now, look at this. Here is the after picture. After they fine-tuned a model using the 3DReasonKnee dataset, look at that jump. Accuracy leaped from under 48% to over 61%. That is a nearly 14-point improvement, closing a huge chunk of that reasoning gap. This is the proof right here that this new way of teaching AI actually works.
So what does this all mean for the future? I mean, what's the big takeaway? This whole breakthrough isn't about replacing doctors, not at all. It's about building a true collaborator, an AI that can work side by side with a clinician, share its reasoning, and help make diagnosis better, faster, and more accurate.
And believe me, this is just the beginning. 3DReasonKnee kicks the door wide open for so many cool possibilities. We could see AIs that learn by doing, almost like a human resident. They could track a disease in a patient over years using multiple scans. And this whole framework, it could be expanded way beyond the knee to hips, hands, you name it, and even to other kinds of imaging like CT scans.
So, I'll leave you with this final thought. The next time you get an MRI, the expert reading it might not be working alone. They might just have an AI partner by their side, one that can not only spot a problem, but can also explain, step by step, exactly how it came to that conclusion. A future with a human AI team in your corner, well, it might be a lot closer than any of us think.